In this section, we're going to look a little bit more of measures of spread and center. So we talked about when you describe a distribution, we should talk about the shape, center, variability, and outliers. And we really focused in on shape. We haven't talked about measures of center or spread or outliers yet. This video looks at measures of center and measures of spread or variability. So there are two main measures of center that we use in statistics, the mean and the median. So for the mean, you probably remember that. That's just where you add up all the numbers and divide by how many there are. What might be new for you is that there's a symbol, the X with the line over it is the symbol for a sample mean. And when you read it, you say X bar. Now this little sigma that looks kind of like an E, that means add them up. So the formula on the bottom is the same as the one you're used to. The X sub I just means the ith term. So you say that's the first term, then the second term, then the third term. So it's kind of just like a way to condense all of the terms and writing that in terms of like a variable. So that is our mean. There's also another measure of center called median, and the median is the midpoint of the distribution. You might remember this from also middle school or so, where you write all the numbers in order from smallest to largest, and you start on the outsides and work your way into the middle. If you have an odd number of numbers, then you'll have exactly one number in the middle, and that middle number will be your median. But if you have an even number of numbers, as you start to count your way in, you'll have two numbers in the middle. When that happens, you find the average of those two numbers. So add those two numbers up and divide by 2, and that gives you your median. So here's a quick example. Here we have a list of 20 numbers, at first just displayed as raw data, and then second displayed as a stem plot. And these are the amount of times that people in New York have to take to get to work. So the top value is the mean of 31.25 minutes. The bottom number is the median of 22.5 minutes. Next, we'll look at some possible measures of spread, also known as measures of variability. The first one is called standard deviation. This one's probably new for you. And we'll run through how to calculate this one time, but it's rather complicated. And really what's going to happen is that you're going to end up putting this into your graphing calculator or a website like Statlet. You're not really going to be finding standard deviation very often by hand just because it's too much work. But we'll look at it at least once. So again, standard deviation is a measure of spread. It tells you on average how far away individual observations are from the mean. So like let's say here we had a set of 9 data points where we asked 9 kids, how many pets do you own? And this is what came out of it. So if we want to find the standard deviation, the first step is to find the mean. So add up the 9 numbers, divide by 9, and then find each of the deviations. So how far away is each of these 9 values from the mean? And then after that, we'll find an average of it. So for now, here is our mean. Our mean is 5. If we added up these 9 numbers and divided by 9, we'd get 5. And for example, the kid that has 1 pet has a deviation of -4. He has 4 less pets than the average. Or this person here that has 8 pets, they have a deviation of 3. They have 3 more pets than the average. So that's what we mean by finding each of the deviations. So here we've done that. We found all of these deviations. Next up, we're going to take all of these deviations and we're going to square them. The reason we square them is because we want some way to get rid of the negative signs. Now you might have done something called mean absolute deviation in middle school. That's kind of similar to standard deviation. It's just a different way of accomplishing the task. So we're going to square all the numbers and then find the average of those values. So here we've squared all of the deviations, and then we're going to add up all of those deviations and divide by how many there are. So we're finding the average of the deviations. So that gives us the 6.5. That is something called variance. So sometimes you will be asked to find the variance. If that's the case, you'll stop here. To get the standard deviation, you just take the square root of the variance. So if we take the square root of 6.5, our standard deviation is 2.55. Now the reason we're taking the square root is because when we were trying to make all of these values positive, so we didn't just cancel them out, we ended up squaring them. So that kind of undoes that process. So this tells me that on average, any one of these 9 kids, if I were to pick them, I would expect that their number of pets would be about 2.55 away from the mean of 5 pets. Now, just like we had a symbol for sample mean, it was x bar, we also have a symbol for the sample standard deviation, which is s sub x. It's a lowercase s and then a subscript of an x. Technically, it could be any letter. You could have s sub y, like sometimes you'll have 2 groups, and maybe you'll have s sub x be the standard deviation of the number of pets owned by students, and then maybe you'll have s sub y be the standard deviation of number of pets owned by adults. So you could possibly have 2 populations, and the subscript won't always be an x, but that's definitely the most common. And then remember, if you square that, that's called the variance. So essentially, here is what we've done. We have taken each individual value, subtracted the mean from it, we've squared it, we've added that up, and then we've divided by n minus 1. The n minus 1 is just because we're trying to take into account that we're estimating a little bit. So because this is a sample rather than a population, we want to take into account that we're going to have a little bit of error, so we divide by n minus 1. And then you'll see we can kind of use the x sub I again, kind of like we did with the mean, to kind of put things together, and then we can use the sigma to kind of notate that. And then if we take the square root of that, that gives us the standard deviation. So there will be a separate video on how to use your calculator. You'll type your numbers into your calculator, and there's a command that will give you all of the summary statistics. It will give you the mean and the median, which are not too hard to calculate, but it will also give you this standard deviation. So you're never really going to be doing the standard deviation by hand again. You're going to be using your calculator or maybe Statlet or another website to do that for you. So we've talked about 2 kinds of measures of center. We've talked about one measure of spread so far, standard deviation, or also variance goes with that. There's another measure of spread that we'll review a little bit later, but interquartile range you might remember. These kind of go together. So mean and standard deviation always get reported together. Median and IQR always get reported together. And there are times when you should use one or the other. The way you know which one to use is based on the shape of the distribution. So we talked about how the shape before could either be symmetric or it could be skewed. If your data is symmetric, you should report the mean and the standard deviation when you're talking about the description. So when you're giving the shape, center, variability, if you said the shape was symmetric, you should report the mean for the center, and you should report the standard deviation for the spread or the variability. If you said that your data was skewed, either skewed to the left or skewed to the right, then you should report the median and the IQR. So if you said that your data was skewed for your shape, for center, you should report the median. For variability or spread, you should report the IQR. So that means if you're asked to describe the data, you have to make a graph of it first before you can report the measures of center and variability, because you need to know whether it was symmetric or skewed. Now, we talked about how to make these data displays in previous sections of notes by hand. There's also a video for how to do that on your calculator as well. So you'll be able to make a histogram on your calculator and then look to see the shape to figure out which of the measures of center or spread that you should be reporting.